Hello everyone, my name is Cyril Loger. I'm a field application engineer in the RF and wireless products. In this short video podcast, we will see today how different a spectrum analyzer is compared to a real-time spectrum analyzer. In order to make this comparison between the spectrum analyzer mode and the real-time spectrum analyzer mode, we will set up the MS2090A into the 2.4 GHz ISM band. Thanks to the touchscreen and the easy-to-understand graphical user interface of the MS2090A, it's easy to switch from spectrum analyzer mode to real-time spectrum analyzer mode. The comparison here will consist of putting the MS2090A into the spectrum mode and real-time spectrum analyzer mode, centered at 2.45 GHz in this ISM band. As this ISM band contains wireless LAN and Bluetooth signals, we will see all these carriers appearing from time to time. No mathematical process will be done on the spectrum analyzer side, so as it sweeps as fast as it can. With the current settings of the spectrum analyzer, the sweep will last 25 milliseconds long. This means that every plot will be refreshed every 25 milliseconds. On the other hand, the real-time spectrum analyzer won't take any time to perform the same acquisition within the 110 MHz band. Since the FFT bandwidth of the MS2090A covers 110 MHz, all the measurements within this band are seen at the same time. It's good to notice that in that case, the RTSA performs 526,000 FFTs per second. You may notice that on the RTSA screen, in addition to the color code density spectrum, there is also a yellow plot. This plot is computed every 50 or 52 milliseconds. It contains more than 28,000 FFTs. This one is very useful to understand about the envelope of the signal, for instance. For sure, the most important information on the RTSA screen is the density spectrum that is color-coded. The color code is quite simple to understand. The more the measurement points are color-coded in red, the more occurrent they are in time, and the more they are color-coded in blue, the less present they are in time. What this could mean in real-life measurements is that CW constant waveforms would be color-coded in red as they always exist, and pulsed signal would be color-coded in blue as they more or less never exist or they are very narrow. So let's now see what a real measurement looks like. What you see here is the spectrum analyzer on the left side and the real-time spectrum analyzer on the right side of the screen. Both units are used in the 2.4 GHz band, observing the exact same frequency span. The spectrogram display, also called waterfall, has been added on both at the bottom of the screen. Even though the spectrum analyzer is sweeping fast, it's not fast enough to see all the transients in the 2.4 GHz band, whereas the RTSA easily shows any kind of carriers or any kind of transient. When a Bluetooth signal occurs in the band, it will go into different frequencies, sweeping across the band. This is what we can see at the moment in the spectrogram display with these red blocks. And when the Bluetooth signal is paired with another device, we can see that the frequency hopping of the Bluetooth carriers is working well, so 1600 hops per second. These hops happen on top of the wireless LAN carriers, but they avoid going into these carriers. Having both the spectrum analyzer and the real-time spectrum analyzer on the same screen, it becomes obvious to see how different the two modes are in terms of data acquisition and speed. Wireless LAN carriers going from the left to the right side of the band can be seen on the RTSA, whereas it's totally impossible to be seen on the spectrum analyzer. The spectrogram that is shown on the RTSA side is being built thanks to the yellow plot I was speaking about. The user can understand about carrier shifting or any transient going from one side to the other in the band. The yellow plot on the spectrum analyzer side shows the frequencies that are being seen almost all the time, like CW's constant waves. Since the wireless LAN and Bluetooth carriers are pulsed signals, it's quite difficult to have a look at them on the spectrum side. The spectrogram at the bottom gives some information, but it's not sufficient enough in that case for a good in-depth understanding of what is happening in the band. Finally, to conclude this video podcast, let's have a look at the two different screen copies that you see on the slide by now. It's meaningless to say that the RTSA includes much more information than the spectrum analyzer can do. For sure, we can use some mathematical process like rolling max, rolling average on the spectrum analyzer, but it won't be fast enough to provide as many information as an RTSA can do. By the way, these two modes, the spectrum analyzer and the RTSA, are complementary to each other. So it's a good thing having both modes in the same MS2090A Field Master Pro. The spectrum analyzer mode and the real-time spectrum analyzer mode can be used either on the field or in a lab, and they will provide all required measurements that a user can expect from a powerful unit like the Field Master Pro. Thanks for listening to this video podcast, and as usual, if you have any information, please do not hesitate to contact your local Anritsu office. You can also visit our website www.anritsu.com. Thank you.